Hi, welcome to the third video on M1 revision, and this is question number 3 that we're going to have a look at. It also on vectors. I thought we needed some more practice on these guys, so here's another one. It says there's a particle P that moves in a horizontal plane, so that's useful because that means we are moving in a plane like that, and therefore we are always in the x and the y coordinates, so we don't have any z's. So in other words, we have I and j vectors, and we don't have z vectors in this question, which is good. Not that it's much more complicated, it just means that sometimes we get 3 simultaneous equations to solve instead of 2. And then they say that the interesting, sorry. Then they say that the acceleration of the particle P is this vector, so they give it in meters per second squared. Obviously that's the unit of acceleration, and that's the vector for A then. So this would be our vector A. And at time t equals 0, they say that the velocity of the particle v is this much. So I'm going to call this v naught, which is the initial velocity at 0 time. And this is obviously into the power of minus 1 instead, because it's a velocity instead of an acceleration. It says find the angle between vector j and the direction of motion of the particle when t is equal to 0. So let's translate things to column vectors, make things quicker. And so here we have an a that doesn't change throughout this part of the question, and the a is a constant of minus 2 plus 3. It's important to remember and realize that the acceleration is always a constant for the questions where the equations of Suvat are valid. So in all these questions, at least for each section of the question where they're asking you, unless acceleration suddenly changes from one part to the other, but throughout the calculation of one single question, acceleration always has to be a constant. So you're never going to see a changing acceleration in these questions. So that's important to know, so we know that this is a constant vector. And now to think about the velocity. So the velocity at time 0 we're going to call v naught is equal to 3 minus 2. So 3 for the I component, minus 2 for the j component. And they ask us for the angle between vector j, which I'm going to draw here. Vector j just points, no, that's vector I always do that. Vector j points up, and it's a unit vector pointing upwards. And the direction of p when time t is equal to 0. And the direction of motion of p is given by its velocity, which is this guy. That velocity tells you what way, what direction it's moving at t is equal to 0, and therefore the angle between that direction, whatever way it's moving, and the j, which is this one, they're asking us for that guy. But let's be a bit more accurate. So what's j in vector and column vectors, just to get some practice? Well, that's the I component. It's got to be 0 because it's not going in diagonal directions, it's going straight up. So the I has to be 0, and the j has to be 1, because the j has a unit vector of 1. So it's good to, j is a unit vector and it has a magnitude of 1. So it's good to be able to draw that, even if we don't need it necessarily here. And let's draw a diagram then for v is 0. It's 3 minus 2, so that's going to look roughly, I just need a rough idea, it's going to look like 3 in this direction and minus 2, 1, 2. So that should look like something like that. Right? That should be v naught. So they're asking us for this angle, in other words, because, sorry, I did it again. They're asking us for this angle. And this diagram, I hope you can see, is vital. Without that diagram we'd get into a mess. So they're asking us for that angle, which I'm going to call theta. And so I'm going to focus on finding this one, and then I'm going to add 90 to it. So I'm going to call this one theta dash, as we did in the last question. This is a magnitude of 3 in the x direction and 2 in that direction. That angle is therefore going to be tan of 2 over 3 from the opposite, TOA. Tan of the angle dashed is 2 divided by 3. So the angle dash is going to be tan to the minus 1 of 3 over 2. Draw a nicer 3, and since the angle that I'm interested in is 90 plus that, then I can write it like this. The theta that I'm interested in is theta dash, which is tan to the minus 1 of 3 over 2 plus 90 degrees. If I do this in the calculator, comes out to be 146 0.3, which is completely wrong because I've just noticed I made a mistake here with the angles. It's not 3 over 2. I had 2 over 3 here, which was correct, and suddenly I flipped it over, God knows why, and so this should be 2 over 3 and that should be 2 over 3, and now we should get the right number, which is 123 degrees 0.7, in other words 124 degrees. So that works okay for part A, but this is quite a long question, so let's get on with the next part and see what they want from us. Now they tell us that at time t seconds, so after t seconds, the velocity of p can be called just a vector v. So they say that at time t seconds there's a very general variable vector v which represents the velocity of the particle. So I'm going to already write down the equation for the motion of v, which is always the original v, or v naught, which we had some information about, plus the acceleration, which is a constant vector, times the time. And we have this guy as much as this guy, and we just don't know this because that's a variable and depends on what moment you're asking. So knowing that as a recap, now let's see what they're asking. Part B says, find an expression for v in terms of t in the form of ai plus bj. So they're asking us specifically for this form now, v in the form of ai plus bj, and it has to include t. It has to include t in the formula. Well, by mistake I just did it there anyway, so now we just need to translate that into this form, and then we're fine. It's a shame we can't do it with column vectors. They're asking us specifically to do it like this. So let's do that. We had from before that v naught was 3i minus 2j. I'm just going to draw them here quickly as vectors, as column vectors, because then I can rewrite them as they want. And that was for the velocity at time t equals 0. So this is v naught, and the acceleration a is minus 2, 3. So we can use these two to put them in there, and then we've got what they're asking us for. So what do they want? They want this general v equals v naught, which is 3i minus 2j, plus t times the acceleration, which is minus 2i plus 3j. And this is what they're asking us to do in this question. It's basically to write this exactly thing, but with i's and j's. So I would still write it like this if possible. If I need to use it in the rest of the question, I will write it again like that, and they won't mind. They just here wanted it like that. So let's have a look at part C. It says, what is the speed of p when t is equal to 4? So find v when t is equal to 4. So that's our general equation, which I'm going to quickly rewrite in the way that I prefer. 3 minus 2 plus t times minus 2, 3. That's the general v, and they're asking us to compute that, to find it, that vector when t is 4. So that's easy. I can write it like this, bit weird notation, but I kind of like it. It's quite neat. Is equal to 3 plus 4 times minus 2, that's minus 8. 3 minus 8 is minus 5, and minus 2 plus 4 times 3, which is 12, so that's going to be minus 2 plus 12, and that's going to be positive 10. So in other words, this is the velocity of the particle and its vector, well, this velocity vector at time is equal to 4 seconds, which is what part C asks of us. And part C is more interesting. It asks us to do something a little bit more demanding, and it's useful. I chose this question because of this part. It says, what is the time t, so So now the question is, what is t? When p happens to be moving parallel to vector I plus j. So normally they say to I or to j, which means either going in j direction or in I direction, but now they say that p is moving parallel to I plus j. What the hell does that mean? Well, a little drawing again does miracles, and I plus j is this vector. If that is I, that's 1 unit in this direction, then j is 1 unit in that direction. So the vector I plus j is this vector, right? I plus j. We translate the j vector to here and we add it, and heads to tails we get our resultant. And so they're asking us for when p is moving in that direction. And what's important about that direction is that it doesn't matter if your vector is 1, 1. I'm going to change to thinking color to white color now. It doesn't matter if your vector is like I've drawn here 1, 1. So 1, 1. Doesn't matter if it's that vector, or if it's 2, 2, or if it's 3, 3, right? If you think about it, this is two sides of a square, 1, 1, 1, 1, and therefore that's going to be 45 degrees. That's 2, 2, 2, 2, so that's going to be 45 degrees, the different size square. And 3, 3 is going to be 45 degrees. So it doesn't matter what the vector is, as long as this part of the vector x is equal to this part of the vector y, then we've got a vector that is parallel to I plus j, and therefore they're asking us here, in other words, what is t when this vector v that is changing is going to have a total same coordinate in the x and same coordinate in the y, when these two are equal. So that makes sense, and we can use that as a clue and as a constraint to write down our equation so that we can figure out what t is at that particular point. So what are we saying then? We're saying that v, which is equal to that formula over there. We need to write the general one because now we don't know what t is. They're asking us for t actually. Minus 2, 3. We know that whatever that is going to be equal to, well, let's call them both x. Why not? We can call them both y's, but let's just say x and x, knowing that these are the same letter in both. And that the difficult thing was to construct this. Once you do this, the rest of the question is easy, but what's tricky to see is that the I plus j direction, then the x coordinate and the y coordinate are equal, so we might as well call them both x's, or both letter a's, or both whatever. And so we can now solve this for x. Once we know x or t, it's a simultaneous equation. We don't know t and we don't know x, but we have two equations, one of them represented by this line, the other one represented by that line, so we can solve it. So first equation says that 3 minus 2t is equal to x. Second equation says that minus 2 plus 3t is equal to x. They're both equal, so that means that 3 minus 2t is equal to minus 2 plus 3t, right, by combining them both together. And so 3 minus 2, the minus 2 goes to the other side as a plus 2. I have 5 here, and minus 2 goes minus 2t to the other side, I get 5t. So in other words, t is equal to 1 second. And so after 1 second, particle p is moving in a way that has equal x coordinates and y coordinates, therefore it's moving in this direction, and therefore is parallel to the vector I plus j. Hopefully that makes sense, and we'll do another video with a different question now. Alright, bye bye.